Welcome, students. So remember, please put Unit 2 up there at the top so that you don't get these worksheets mixed up with Unit 1. All right, so how are we going to be using these ordered pairs that we talked about? An ordered pair, there's supposed to be some sort of link between your x value and your y value. It doesn't have to be a mathematical link necessarily. You can have relations where you're using like words or ideas or, I don't know, people and addresses. There are many different things that can represent relations. Um, and it's a term used frequently in computer science. They use a lot of relations. Math will use much more functions than relations. So a relation is just a set of data. I'm spelling relation right? Yes. It's a set, it's a data set of ordered pairs. So when we're talking about sets, like we had a set of answers to X when we did absolute value. So we use our curly braces. And so if you have a set of data, like let's say you're recording some observations in science, okay, and you've got your independent and your dependent variables, your cause and effect, and we'll just list off all of the pieces of data you collected. It would look like this, okay, if they were ordered pairs. So it's just a string, basically, of ordered pairs, like that. And so I'm saying, hey, all of these ordered pairs, they belong on a single coordinate plane. They're all representing some sort of relationship or relation. And so graphing these, remember X and then Y, we can graph them all on one graph, basically. If it's a relation, it belongs on the same graph. So 0 for here's my origin, 0 on my Y number line and 3, sorry, I said that wrong, 0 on my X number line, my X axis, and 3 on my Y. There's the first one. These ones don't have names, notice. For the second ordered pair, the second point, it's negative 5, 4, so negative 5. 1, 2, 3, 4, 5 along my x axis and 4 on the y. 1, 2, 3, 4. So right here. For the next one, it's at negative 1, negative 6. So negative 1 on the x number line, negative 6, 1, 2, 3, 4, 5, 6 on the y number line. That's down there. And then 4 on the x number line, so 0, 1, 2, 3, 4, and then 4 on the y number line, up 4 then, 1, 2, 3, 4. It's right there. So these 4 points on my coordinate plane are a relation. They're a set of points that belong together on the same graph. Now, we want to look in math at a very special kind of relation, and it's going to be called a function. A function is an equation. Actually, that's wrong. It's an expression. And sometimes we call it a rule that takes a number, an input, which we will call our x. And it produces or generates a single output. That's not 2 words, Mrs. Grace, it's 1 word. Okay. Which we are going to call y. Okay. So one way to think about when we talked about this, that we have, what do we do when we have 2 variables in our equation that we're trying to solve? Well, this is very difficult, right? You just have to kind of guess. So you're like, well, if If x is 3, then that means y is 4. If x is 2, then y must be 7. If x is 1, then y must be 6. If x is 0, y must be 7. What about negative numbers? Oh no, negative numbers. If x is -1, then y is 8. Oh no, we can keep going. We can keep going forever and ever and ever. Well, sometimes it's kind of hard, but you notice how I was choosing an x and trying to figure out what y would have to be if I had that particular number for an x. There's an easier way to do it and think about it, and that's if I take, and instead of having my two variable equation look like x plus y equals 7, if I were to rearrange it, ooh, just like we did with literal equations, what if I subtracted 1x from each side? And I ended up with something that looked like this. Okay, now I haven't changed anything. This is really the same equation. I've just moved some things around. But now it's a function. This technically is my function. It's an expression where I can keep putting in numbers, my input, for my x, and it's going to produce a number that's my output. All right, so it's just taking those two variable equations, any kind of two variable equation, and making it so that I have my one variable on one side, usually we call that one x, and then it's going to have just equal to a single thing, my y. So basically we solve for y and we get our function. So this is the function, or sometimes people call it a function rule, where we'll be putting in numbers and it spits out another. We think of the function like a machine. It's an expression. Any expression can go in here. And I'm going to be able to put a number in the place for x, and it's going to spit out for me. It's going to go turn, turn, turn. It's going to do all its little operations. It's going to spit out a y for me. So the x value is called the input. We know that already, Mrs. Grace. It's called the input, and that means it's going to be my independent variable because it's the one we get to choose for ourselves. Okay, and once I put it into the machine, it's going to spit out a number depending on what the rule is, and that number is dependent on what I put in for the x. Now, because, and if you just think about it for a little bit, because we're going to have some sort of algebraic expression that's going to be our function rule. If I put a number in, like let's say I put in a 3 for my input, I'm never, ever going to get anything other than a 4 for my output in our little example function over here. Never going to happen. All right. I can't put in a 3 and expect a 5 to pop out. I can't put in a 3 and expect a 1 to pop out. The rule is going to make it so that every input that I put in is only going to have a very particular output that it comes out of, that comes out with. So we do have to be very careful about that when we think about functions. So we're going to practice right now just taking our function and our function rule and putting in inputs and getting out outputs.